Section 2, Unit 5, Quality Assurance, Process Planning, and Quality Control. This chapter discusses actions supporting machining, plans and processes to be effective and efficient, quality assurance, plan or system of activities for meeting customer needs, strategy and steps for performing machine operations. Major steps include material selection, machine selection, and work holding, tool selection, speed and feed calculation. A fairly simple example of the process plan for producing a machine component. So this breaks it down into operations, what's going to be happening in that operation. So you're going to saw the blanks, CNC mill, deburr, and clean. Inspecting dimensions to make sure tolerances are met. Sampling plan tells how many parts are inspected and how often. Inspection plans tell critical dimensions to inspect and by what method. Statistical process control, or SPC, tracks size variation, uses control charts. An example of sampling/inspection plan, it shows that 2 dimensions of 3 parts should be inspected every 2 hours, and what inspection method should be used. So, part subgroup, part 1, the print says it's 0.882 plus or minus 2 thou. It actually measures 881. The prints on this one is 1.75 plus or minus 5 thou, and it's actually measuring 1.749. So they go through and do all the subgroups like that. This is John, Jim, you know. Explanation of the parts and of the X-bar chart. First you get your range. These values are on the X or Y-axis are for plotting averages sizes of the parts from the subgroup sampling. Each plotted point is the average size from the subgroup sampling, and this line here means or shows the average of the subgroup sampling average sizes. So if it's staying in the center of the upper control limit and the lower control limit, then you know you're good. The X-axis shows the subgroup samplings. So subgroup 1, as you can see on this last one, subgroup 1, 2, 3. Alright, X-bar chart shows that the machining process is in control because the average of the subgroups is well between the UCL and the LCL. Note that the mean line is close to the midway point between the UCL and LCL, so upper control limit, lower control limit. These average values are from the subgroup number summaries listed in the sampling inspection plan on figure 252. So back to this one. But anyway, if an X-bar chart shows a trend of moving toward the UCL, steps should be taken to adjust the machining process to begin the process closer to the desired size. Note that the mean line also moved toward the UCL. That is because the mean or average sizes of the sampling parts are increasing. So the average values are on the subgroup numbers summaries listed from the sample inspection 252. On this one, it shows it going down to the LCL. But if the X-bar chart shows a trend moving towards the LCL, steps should be taken to adjust the machining process to bring the process closer to the desired size. Note that the mean line has also moved towards the LCL. That is because the mean or average sizes of the sampling part is decreasing. Large spikes in X-bar chart show that the process is not very stable, even though the mean size seems acceptable. Steps should be considered to stabilize this operation because of large variation and because sizes are getting too close to both the UCL and LCL. The X-bar chart is most likely what would have happened with the process from figure 255 if no corrective actions were taken. Sizes have continued to increase and the graph has risen above the UCL. The machining process is out of control. Note that that mean has also moved closer to the UCL. Explanation of parts of the R chart. Y-axis shows the range of parts from the subgroup sampling. The X-axis shows the subgroup sampling just like the X-bar chart. Each plotted point is a range of the subgroup. the mean shows the average of the range values, and the LCL is always 0 because the difference between the sizes can never be less than 0. The R chart shows low variation because the graph and the mean line are close to the LCL. Remember that a decreasing or low value R chart graph does not always mean the machining process is in control. Analysis of the X-bar chart must be also used. So all of these plotted range values are from the subgroup number summaries listed in the sampling inspection plan. At the time of sampling 6, this machining process has become out of control, indicated by the R chart graph cross above the UCL. Note that the mean is also near the UCL. This increase in R graph should have caused an alert by subgroup 5. Then adjustments might have been made to prevent the range subgroup 6 from rising above the UCL. So pretty much it's saying if you use these control charts that if you see a trend of it going one way or the other, you can stop it before it goes out of tolerance.